Okay, so the next stage of our data center virtualization planning would be our virtual network planning. Once we have our ESXi hosts installed, we need to attach them to the physical environment, of course, so they can talk to each other. We also need to establish the virtual network environment. We're going to use two physical networks, which will also be tied to different aspects of the virtual network. One of these, in our case, with the topology we're working with here, this one, we've got our management network here and our NAS. That's one network tying into our VM kernel ports, and the other network, the production side of things, is tying into the outside world through the router, through the firewall to the cloud. So we add these so that we add these in. Then we can begin establishing virtual switches. This is a little different from what you've done so far with VMware Workstation. If you've ever created a virtual LAN segment, it's kind of like that, but fundamentally different. These virtual switches are software constructs in the hypervisor. Basically, what we've talked about in the past about network functions virtualization. This is precisely what we're doing. And they can either tie into your virtual NICs or your VM kernel NICs. Your VM kernel NICs are going to be used for management, for storage vMotion and vMotion, for heartbeats, so the vCenter servers can talk to the VM for the agents, etc., etc. And so we've got the management network and the production face. It's all the production network, but you've got your management in the back end, tying into a NAS, or if there's actually a SAN back there, maybe there's almost a third network. Anyway, so vSphere provides two different kinds of switches, standard and distributed. With your standard switches exist only on a single vSphere hypervisor, and if you have the unlicensed ESXi host, that's literally all you can do. If you need to have the same kind of situation on more than one unlicensed ESXi host, you're going to have multiple copies, as it were, of the same standard switch. So you can manually pick up and move a VM from one place to another. But it is not going to be able to automate that for you in any way, shape, or form. The distributed virtual switch, and what you essentially do is you create your virtual switch in your vCenter, and it propagates those to your ESXi hosts, so that you can have ESXi hosts on multiple devices, all behaving as though they are essentially talking to the same distributed switch. If it would be like a standard switch, it would be like a physical switch. It can only be in one place, and if it's in one place, or even a VLAN, which only exists on one physical switch, the distributed virtual switch would be like a VLAN spread across multiple physical switch chassis in a campus area network. Now, our virtual switches have three different kinds of ports. There are virtual machine ports. These handle the traffic between your VMs and between your VMs and the physical network. Your VM kernel ports, these are all management, remote consoles, network storage, vMotion, fault tolerance, that kind of thing. The VMs don't talk to each other using VM kernel ports. The hypervisors talk to each other and the vCenter server using said VM kernel ports. Then you've also got your uplink ports, which actually tie your virtual switches to the physical adapter and then the physical network. Now, you can actually tie two or more physical network adapters to the same switch. This is what we call NIC teaming. And then there are a number of different ways to do this, which we will get into later. One of these, NIC teaming is essentially, it's like Ether channel or channel aggregation, using, say, the link aggregation control protocol, LACP. or in a Cisco environment, port aggregation protocol, PAGP. It's the same concept here. There are many different ways to do this, from the very, very simple to the very, very complicated. No. So we can do this. We can set up these network policies. These increase our performance. They provide fault tolerance in case a switch or a network adapter fails. NIC teaming can also do things like load balancing, so that if you've got multiple VM ports, VM NICs tied to multiple physical ports, it can figure out, okay, how do I send traffic across these? How do I spread the load balancing? In terms of building these things, creating these things, we're going to use the vSphere client, the web client or the vSphere client. We can create, remove, and change, or create and remove switches, change their properties, change the number of ports, set up speed and duplex properties. Now, if you're using a gigabit NIC on your on your physical platform, and the chances are that you probably are, if you're using modern equipment that is capable of handling the load you're going to throw at it, you're going to be using gigabit NICs at the least. Leave all these settings as auto-negotiate so that physical NIC can talk to the physical switch and figure out speed, duplex, all that stuff, because all that is in is done for you in the latest versions of IEEE 802.3, which of course is the Ethernet family of standards. Our virtual switches also support VLAN tagging. So you can put different VMs into different broadcast domains. You can also, of course, if you've got that, you also need a trunk port. So remember what you know from your TCP/IP and routers courses about VLANs, trunking, and tagging. The difference here is that we learned in our networking courses that the switch does the tagging, not the end device. But now, because we virtualized the switch and moved it inside the end device, it can tag things. But of course, what that means is that for all intents and purposes, if you've got virtual switches providing their own VLAN tagging, your physical NIC has to be, the physical NICs, the uplinks, have to be trunk ports. And the physical switch that you're tied to has to know that it's talking essentially to another switch with a trunk port, etc. So let's look at that. Kind of looks like this. So you've got your production VMs, you've got some NAT clients, and there are many different ways to do this. You can have a production VM talking to a VM kernel, talking to the physical NIC, and going down there. You can have a VM as a NAT client talking to a NAT router, also a VM, talking to a VM kernel NIC, talking to a physical switch, and maybe there's some redundancy there, say some load balancing and some NIC teaming right here. You can also have your management network. You have VM kernel NICs, maybe not talking to anything at all, down to your physical switches or your management network. There's lots of different ways to do this. Now, we talked a little bit about load balancing and traffic shaping. That's what we're going to get to in the next video, network switch policy. So thank you for watching, and we'll be right back.